I would like to welcome Sofia Nilsson, just came in from Sweden.
Yes.
Sofia works for SICK, and Sofia is going to talk about Ruler3000, the fastest way to high-performance 3D. So, Sofia, the floor is yours.
Thank you. So, hi everyone. My name is Sofia, and I'm product manager for 3D streaming cameras at SICK. I'm very happy to be here today to be able to present our latest innovation, Ruler3000, or the fastest way to high-performance 3D. So the agenda for today is first some introduction and background to this camera, followed by where will this camera provide value in the industry. And finally, I will show you some example applications and some captured data. So let's get started. What is this camera? Well, it's a 3D streaming camera based on laser triangulation. And with 3D streaming, I mean that the camera will only send out images, and you need a PC or similar to connect and do the image processing. This camera gives you superior 3D data and great performance by SICK ROC technology that I will tell you more about soon. And what's really special with this camera, that's the outstanding speed. Up to 46 kilohertz in full resolution, 120 rows. That's as fast as you can run with this camera, and that's outstanding. You will get highly accurate and reliable 3D measurements from 60 millimeters for the smallest field of view up to 1.7 meters. So we have several field of views to fit a wide range of applications. You get a compact and industrial housing and direct integration to third-party softwares like Halcon, etc., since we have GenICam and GigaVision standards. Of course, you get factory-calibrated 3D data, but also reflectance and scatter image to be able to solve complex applications. And also, we have had a big focus on making this camera easy to use. So we made a new user interface and a new API to make it as simple as possible to use. So a few words on what is so special about this camera. That's the CMOS sensor in the camera, developed by SICK. So we did this sensor 3 years ago and have had it in our Reindeer 3 camera since then. And it has what we call a ROC, rapid on-chip calculation. That means that we have 2,560 processing units, one for each column. So once the sensor grabs an image, all those processing units will in parallel search for the laser line and only send the height information of the laser line to the PC. And that's what makes it so fast. The resolution is 2,560 times 832 pixels. And that means when running in the highest speed, we process 15.4 gigapixels per second. So, as I said, we don't only provide 3D, but also reflectance and scatter. So I will say a few words on what that is. So reflectance, that's the amount of light reflected in the center of the laser line. So in the image below here, you see a board with a laser line, and the red line here symbolizes the center of the laser line. And that will give you the reflectance image, meaning that dark things get dark, bright things get bright. You can see the reflectance image in the red box there from that board. Whereas the scatter image measures how much light is reflected a few pixels away from the center of the laser line. And that's showed by the blue dashed line on the board. And that means that tells you how much the light is spreading inside the material, and could be very useful for organic matters like wood and meat, for example. So in this example, you see the scatter image in the blue dashed box. And you can see that the knots of this wooden board are really dark, since the light is not spreading very well in the knots. But in the fibers, the light spreads much more. It could also be useful, for example, distinguish between fat and bone in a meat application. So as I said, we have a number of different field of use. And it's ranging from the smallest one that we call Ruler3000. The last digits in the name corresponds to the field of view in centimeter, approximately. So around 8 centimeters field of view. And then we have the Ruler3020. That's actually the only one we have launched so far. The other ones are coming out very soon. We have the 3060 and the largest 3120 with a field of view up to 1.7 meters. So, where can this camera provide value in the industry? Of course, in a lot of different areas where high resolution and high speed matters. So I have done some examples here, a few for each field of view, just to give you an idea on what it can be used for. So the smallest ruler would provide a lot of value in electronic assembly industry, as well as battery industry, since here both high resolution and high speed is of big importance. For the 3020, tire building would be an area where this camera would provide a lot of value, since it has a very light-sensitive sensor, and that's ideal for those dark tires where it's hard to get enough light. And for this smaller field of view, tire sidewall inspection is a good fit. Also, in consumer goods, packaging are interesting applications, since they run often in very high speed. For the Ruler3060, we also think tire building will be a big area for a bit larger field of use, as well as the food industry, where you do, for example, portioning or quality inspection, where you also have very high speeds. And finally, for the largest ruler, we see the wood industry as a potential customer, and that is especially due to the scatter functionality that can distinguish between bark and wood, for example, and the knots, as I showed you before. And also we think logistics is an interesting area here, since you typically need a large field of view, but still very high resolution to detect like very thin envelopes, but also high speed. So let's continue with some examples of applications where we think our camera can provide value. So I'll start with battery inspection. So batteries for electrical vehicles are a growing industry, where we see a large need for 3D high precision inspection. So some areas in the battery industry would be battery cell surface inspection, where you would look for defects like scratches and dents in the surface. Another area is battery welding, battery cell welding inspection, to detect incomplete and misaligned welding seams. So the image here, for example, shows the left image shows a number of battery cells put together in a module, and then the cells are connected with bus bars where the welding seam needs to be inspected. And next in this process, those modules are put together in a large battery pack. And here you need surface inspection to ensure that there are no foreign objects that can damage the enclosure of the battery during or after assembling the chassis. And for all those applications, typically defects down to 0.1 millimeter should be found, and scanning speeds can be up to 500 millimeters per second. So both speed and resolution matters here. So to give you just some theoretical examples on how fast we can run, I have made 2 examples here. So of course, it's very dependent on the exposure time, how fast you can run. But let's say you are happy with 30 microns exposure. That means you can run in approximately 30 kilohertz. And if you would have a conveyor running in 2 meters per second, that means it would be 66 microns between each profile. And let's say you're happy with 20 microns exposure, then you can run even faster in 46 kilohertz. And for a conveyor belt traveling in 1 meter per second, that would give you 22 microns between each profile, just to give you a feeling. So next application I want to mention is glue bead inspection. Applying glues or sealings in the production of electronic devices is increasingly important. And since the components often are very small, it's not an option to use screws or similar. So the Ruler3000 camera measures the shape and the positioning of the adhesive with high accuracy to ensure high product quality. And here I have made a scan of a 6 sensor that you can see in the image or the photo at the bottom. So it's a 6 distance sensor where the electronic is not in place yet, but we have this thin black glue at the top of the sensor where a lid will be put on. So I have made a scan of this just to show you what the data can look like. And now I hope I can start this video. Yes. OK, so here you see the 3D data of this sensor, where this blue line is the glue bead. So let's zoom in here to see some details. Zooming in here, you can see there is a blob of glue in this area. And moving closer to the corner, you can see in the corner the glue bead gets very thin. And looking further here, you can find a part of the glue bead that is a bit wider. And around this hole, you have a circle of glue, where the glue is sort of overlapping in this position and gets a blob of glue, basically. So as you can see, you have a lot of details in this 3D data. That would help you to ensure the product quality. So finally, I want to mention some wood applications. And now we are mainly talking about the largest ruler, the large field of view. And wood is a material which by nature has a wide range of geometrical shapes, quality features, and defects. And a modern sawmill of today has an enormous throughput. So every % of increased yield is a lot of money for the sawmill, and also, of course, good for the climate. So one application in the sawmill is a log scanner that you can see in the top right image. So here you typically have a number of cameras mounted like in a circle around the log. And the application is to optimize the saw pattern of this log to get as many boards as possible out of this log. And here, scatter can be very useful to distinguish between the bark and the wood of this log. Another application is a board edger that is shown in the bottom left image. So here the camera measures the width of the board and detects the wane edge to optimize where to cut the board to get as much yield as possible. And here is also both reflectance and scatter image of great use to optimize not only the 3D shape, but also the quality of the boards. So I will show you some data captured from some wood applications. So the first one here is a block of fir. So that means it's a log where you have sort of removed these two sides. And fur is typically a material that has very bright knots, so it's hard to see them in the reflectance image. I will start this video, hopefully. So here you have the reflectance image overlaid over the 3D data. And here you can guess that it might be knots, but it's hard to see in this reflectance data, since they are very bright. I'm here switching to scatter data. And now you can clearly see that we do have a knot here. And going back to where we started, you can clearly now see those two knots in this scatter data. So let's switch to a log. So here we do have a log with the scatter data overlaid. And you can see a very big difference between the bark and the wood in this scatter data. The bark is the dark part. Switching to reflectance data, you don't see the bark anymore. Zooming in, though, you see a lot of 3D details and the reflectance data here. Okay. Thank you very much for listening. That's all I had to say today. And you can find SICK and learn more about our solutions in Hall 10, booth D58. So very welcome to visit us. And maybe we have some questions first.
Yeah. Thank you, Sofia. Some questions from the audience, maybe, or from those participating in the stream. I'll check the panel. You're all welcome to ask questions. However, you have to scan and log in, and of course, then you are welcome to raise your questions. I don't see any, so I'm sorry, but I might have one. So we do a market survey. We ask the European machine vision industry, no? How are you developing? What trends and applications do you see? And what we get is, for years now, 3D products and applications increasing demand. So we monitor like the development.
Yep.
So do you agree with it that, well, it's really picking up now?
Yes, I would say so, and I also think you can see that at this fair, if you compare it to, I was here first time 2014, and you can see it's more and more 3D products popping up for every year. Yeah. So yes, I think definitely we have increased demand of 3D solutions in vision.
Thank you.
Yeah.
So no further questions? Then I would like to say thank you again, Sofia.
Yeah, thank you very much.
Overview. Exactly, let's give her a hand.